So now we're going to do everybody's favorite, 1.5, modeling and solving problems with polynomial functions. And I'm joking when I say favorite. A lot of people really don't like word problems. But if we can translate this word problem into the math part of it, then it actually is relatively easy. So what we got to do is we have a cardboard box. We all know what a cardboard box is. But the width must be 2 centimeters less than the length, and the height must be 5 centimeters less than the length. So write an equation for the volume of this box. We're talking about volume, so we're talking about like length times width times height. So in this thing, let x equal the length, because everything's based on the length anyways. So the width would be x minus 2, and x minus 5 would be the height. So what we have is we have our length, width, and height. And to find the volume, all we do is multiply those together. So here's our formula right here. So volume of x, so v of x equals x times x minus 2 times x minus 5. And the order doesn't matter because it's just the 3 multiplied together. Okay, so that's part A, just to find the equation. Now, if they tell us that the volume is 70, what are the dimensions? So this is where we have to work backwards. So over on B here, we can look at that. Here, let me get a highlighter going here. We can look at that, and so we have x minus 2, x minus 5 equals 70. So there's our equation. The only thing we've replaced is we replaced the volume with 70. Well, how do we work backwards? Well, you're going to have to do some foiling, right? You're going to have to do some distributions here. So x times x and x times negative 2, and then you can FOIL this, and you get a big, long polynomial here. Well, what do? Collect like terms, rearrange, make it all equal to 0. So if you look, we end up with x cubed minus 7x squared plus 10x minus 70 equals 0. There it is. There's our cubic. Okay, well, to do this, we need to factor the whole cubic. So what we do is we use, remember, binomial remainder theorem, and we try different things. Now, if you look, the 70 is kind of the giveaway. We always want to look at factors of 70. So you try 1, right? You would try 70. You would try, now, obviously it can't be 1, because if you had 1 and then 1 minus 2, you can't have negative width there. So it can't be 1 in this case. 70 would be too large, so it's probably some of the middle ones. So in this case, we could try 7 and 10. So I try 7. So we plug in 7, binomial remainder, plug it in. Oh, we end up with a good old 0 there at the end. So we know that x minus 7, which is the binomial, right, is going to give us one of our answers because we get 7. So how do we do it? Well, synthetic division. Plug all the number coefficients in, 1, negative 7, 10, negative 70. Plug it in, bang, we get this. We know it works because it ends with a 0. And then here we end up with an x squared plus 10. Well, that's kind of weird. Now, if you look at this, this x squared minus 10, you're thinking, well, I need to factor that. Well, doesn't factor very nicely. You might try quadratic, but something you can remember from grade 11 is we did the discriminant. Remember, the discriminant tells you if there's any answers, or if there's 0, 1, or 2. So in this case, slap in the discriminant, we find out it's going to be negative. So this x plus 10 here is just irrelevant, right? It's like an extraneous piece of information. So we know that x has to be 7. So then if we know x is 7, the length, right? Then we can figure out the width because it's 2 less from it, and then we can figure out the height. So based on that, and then if you do a quick one here, right? 7 times 5, 35 times 2. Oh yeah, 70. That was the volume that we were given. So it comes down to honestly, the hardest part about this would probably be setting up the equation, taking the information written up here and turning it into an equation. But once you get that, it's still the same pattern, right? Get rid of all the brackets, collect all the like terms, get it equal to 0. Then to factor it, you try the binomial remainder theorem. If you find something that gives you a 0, then you can factor it. And then once you factor it, you can figure out your answer. Okay? Flip the page, and we got one. This is from January 2018 provincial exam. I like these questions from old provincial exams because they really give you an idea of what the province requires. So what it is this picture and stuff is not here. This was the question. State a possible value of n, right? So talking about n right here, of the polynomial function that has a range of 0 to infinity. So there's the giveaway, right? If it's 0 to infinity, the range has to be above the x-axis, right? And since the leading coefficient up here is a 1, it's positive, both ends have to go up. So we know if we draw this, right, bang, 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 right? And you can actually figure out, okay, so x plus 2, so one of them has to be at x minus 2. X minus 1, so one of them has to be at 1, right? And you can actually plug in a 0 into the x's and see what it is. Well, the only thing that this could be, this has to be an even polynomial. So n can't be 1 because that would make it odd, right? A 2 and a 1 would be a 3, right? N can't be 3 because that would make it 2 and 3, that would make it 5. So, right, it has to be a 2. So a 2 and a 2 and a 4. Yeah, that's our 4 right there, the x to the 4. So n has to be 2. And a question like this, you always have to make sure you state, if they ask you specifically, if you drew a picture and did all that, you still have to state what n is. That's a great question from the provincial exam. It really makes you think about what polynomials look like. So that was 1.5.